Let me, before I even do that, uh, let me make myself darker because I'm tired of this light shining in my eyes. Here, let me see what this will do. Rawr.
Did you just
Probably not
roar?
help. What'd you say?
You said roar.
Sorry for my now kind of dark face, but sure. Thanks for bearing with me. So I wanted to first of all say that I have transferred all of us into a new Alex class. That way we
Hey,
don't have to deal with all those crazy assignments that are there from first semester. We're just looking at this semester's assignments in Alex. I, the only thing it didn't transfer was your work on the two assignments we've had so far this semester. I did go ahead and put those assignments in, and then by hand, I manually put your scores for each of those assignments in. So it's a little bit goofy that way, but at least your scores are in there. And yes, there are far too many of you that don't have a score on your 121 and 122 Alex assignments. So you really need to do something about that. But just wanted to point that out. So it's going to look a little different. The name of the class is different. The content's pretty similar, except it might have a little more of the before algebra stuff in it than our other class did, but it has our textbook content in it, so we're good. Um, so I wanted to mention that. And then this week's been crazy, ladies and gents. Aside from Mr. Reed choosing to, just be a lame absent teacher yesterday, we had a snow day. So let me just remind you what the heck's been going on. Last Friday, a week ago today, hi Jada, thanks. Um, a week ago today, Mr. Reed for the first time ever tried a Pear Deck. And I was hoping to do, half a class with review and then the other half quiz. Didn't work. We spent the whole day Friday working on the review. And then Monday, it was all about discrete function versus continuous function. So Monday we did this quiz is about discrete versus continuous functions. So that was our main focus Monday. I did remind everybody, hey, if you haven't completed the Desmos activity that we've spent 3 class periods on, please try and get that done. Monday. Tuesday, hello everybody, it's a snow day. Wednesday, oh, it's our asynchronous day. Mr. Reed just said catch up. And then yesterday, Mr. Reed was not feeling well, so I was absent. I said, keep catching up, but if you're all caught up, try and do at least 2 topics in your Alex pathway. And here we are to another Friday. And since last Friday we tried Pear Deck, I thought this Friday we should try Pear Deck again. Friday and Pear Deck is just a whole new theme. I am, thank you, Jalea. I'm definitely feeling better. At the moment, I feel a little tired again, but not anything like I did yesterday morning. I'm happy to say. So thanks for asking. So today, what we're trying to do is move on to, this is module 3, lesson 4, I think, in our textbook, if you were looking at our textbook. But all that our focus is going to be is being able to identify equations, identify whether an equation is a linear equation or not. So if we look at our learning intention for today, I can identify a linear equation. I can identify, this really is not a new criteria, but just making sure we're all good with it. I can identify ordered pairs that are a solution to a linear equation. And then I can identify equations that are linear versus equations that are not linear. So that's kind of what it's all about. These examples have taken most classes, a large majority of class. One class had almost 15 minutes to work on an Alex assignment. Other classes had next to no time. So kind of like last Friday, this assignment that was supposed to be due today, I'm going to give you a little bit of time on Monday for sure. So I'm telling you, you don't have to go crazy if we don't have time in class today. You're not obligated to get it done. Sorry, that's the second Friday I've said something's due on that Friday and then changed my mind. Not right now, Julia, or not right now, everyone. Maybe we can do that towards the end of class. But here's y'all's Instagrams. It's called a Pear Deck link in the chat. Go for it. And while you open that Pear Deck, you also you do want to pull up Desmos, because I'm going to ask you to do some stuff in Pear Deck that having Desmos right there to do will be very helpful. I think that covers pretty much everything that I wanted to talk about before Pear Deck. So you could just go to joinpd.com and enter this code. You can follow the link that I stuck in the chat. And no more Instagram addresses at the moment, please. Let's get focused on math for a while here, and then maybe toward the end of class we can do that. We got 6 of us connected. Really, that's 5 of us because I'm one of the 6, and we got 22 people. Well, that's really 19 people in class, so I'm thinking we need a whole bunch more people in this Pear Deck. It is a participation grade. Here, while people are climbing on the Pear Deck, I'll show you a little something. This is last Friday's Pear Deck. One of the many things that is nice about Pear Deck is I can export all your hard work into a spreadsheet. And then I made it so this spreadsheet was highlighting anything that was an incorrect answer. So it made it really easy to look and say, oh, well, this student didn't answer anything until we got here, and that was the wrong answer, but then we had some right answers. I haven't put these grades in yet, but this is what I'll use to create grades from last Friday's Pear Deck for participation. Just because you got it wrong, since a participation grade doesn't necessarily mean I'm going to take a bunch off for that, though. This class was pretty good. I tried very hard to say, hey, here's the correct answer, please correct it, so I know you are with us and you are participating. So that will have a participation grade for today's Pear Deck as well. Moving right along. We got 12 of us in. I'm needing the other 7. Did you say what 12 are in? Sure, I'll be glad to tell you that. The 12 that are in would be Anas, Angelina, Anusha, Damon, some Mr. Reed dude, Jalea, Kevin, Lania, Matthew. Man, there's all kinds of people that are here with us that I haven't said hi to. I apologize. Nevaeh, Funstock, Trinity. So I'm sorry, guys. Like, I think maybe I did say hi to Aiden. Don't feel like I said hi to Kevin. Don't think I said hi to Matthew. Well, maybe I did. I'm not sure. Sanai, Trinity, Anusha, Kiwan. Kiwan is not a new student to Algebra 1, but he did get bumped from one of my other classes to this one. So welcome, Kiwan. And we got Nevaeh and Funstock, Anas, I've said hey, Angelina and Damon, Malcolm and Kadisa. Okay, I feel a little bit, I think I've said almost everybody's name, that is. Lania, I'm not sure I said hey, Lania or Micaiah. All right, here we go. So, identifying linear equations, we're gonna first of all start with just figuring out what ordered pairs are a solution of a linear equation. So you see your 4 dots. The top one I think is red, and then orange, yellow, and green. We're going to use those, drag them over to the appropriate yes or no column. So 1 dot for each of these ordered pairs. But let me just give you a reminder what's going on here. It says for each ordered pair, determine whether it is a solution to this equation, 7x plus 3y equals 2. And so, as I said, I'm thinking this is more of a review, but this ordered pair, x is 5 and y is 2. Come on. Why is it being difficult? There's my y. So if I plug it into this equation, 7x plus 3y equals 2, I'm now going to have 7, replace the x with the 5, so 7 parentheses 5 plus 3 instead of the y, it's now going to be a 2. And the question is, will that produce a value of 2? So this is where I'm saying we should just take advantage of Desmos, www.desmos.com. Let me get that out of the way for a minute. Actually, let me bring that back for a minute, and let me stop talking, make this kind of like so. So I'm going to delete what I've done earlier. This is a 7 parentheses 5. I'm just using Desmos to do my arithmetic for me, and I don't need the equal part right now. All I'm trying to find out is what does 7 times 5 plus 3 times 2 equal? And you see right there, it's giving me an answer of 41. So seeing as I needed an answer of 2, it is not a solution to this equation, is what I'm trying to say. So let me drag this now. Okay, there we go. Drag that guy back up there. And then we just got an answer of 41. So clearly 41 does not equal 2. That's the reason I know it's not a solution. It's not a solution unless it makes the equation true. Okay. I'm going to do the same kind of thing with -1 and 3. Rather than write it out like this, I'm just going to go back over here to Desmos. Stop it. And put in, okay, all I can figure is it's real and truthfully. There was my X, there was my Y, and here we've got -1 is our X and Y is a 3. So I'm pulling Desmos back up, putting that -1 in place of X, and putting that 3 in place of Y. And looky there, Desmos is already telling me that that does produce an answer of 2. So we just found out that the second one here is a solution, because when I did 7 times -1 plus 3 times 3, I got an answer of 2. So this is a yes, and that's where I'm expecting to see all your beautiful answers going for the second one. Okay, so real quick, if we just share, whoops, everybody's responses so far, we should have everybody's response for the 5,2 ordered pair on no, and the -1,3 ordered pair should be on yes. We'll just move that stuff out of the way. And I'm asking you guys, see what you can come up with for 0, -8, and 2, -4 right now. I'll hide responses for the moment, but that looks like we still got one person on a no for the second one, the -1, 3, and it should be a yes.
You're not a fat pig, Mama. You're a fat whale.
What you saying, Aiden?
How dare you?
All right. So I had already said that this was a no, because remember we got 41 when we plugged in, but this was a yes. We got 2 when we plugged -1 and 3 in. This one is definitely a no, because we would have gotten -24 out of that. And this one should have been a yes, because it does produce an answer of 2. Do we have questions about it, guys?
No, sir.
All right, that was a no, sir, from one person. Does anybody else have questions about how we found those answers?
There was an incident yesterday.
Well, that's an interesting question.
Yesterday there was a balloon that I had got, and I couldn't find a Sharpie, so I drew on it with a pen, trying to make a face, and it wasn't seeable. So I tried scribbling it. it still wasn't seeable, so I was beating the balloon and it popped, and I named it Malcolm Jr. And yeah, I'm supposed to be having a funeral for it today. It starts at 6 p.m.
Hey, Malcolm,
Yes.
thank you for sharing that. Um, the correct answer for the second to last one should be no, and the correct answer for the very last one should be yes.
You see, I got. Can't put this.
Yeah, yeah. Balloon abuse. All right, let's keep rolling here. I don't want to spend too much more time on this type of a problem, but let's go ahead and do the, this is just the answers and just trying to make it really clear. This is Alex's explanation because this is all coming straight out of Alex. And so they're showing the actual process of finding the answer. We're doing it in Desmos instead. But the important thing is to understand when you get a situation where the two sides of that equal sign are not equal, then that's when we know it's not a solution. When they are equal, then it is a solution. Not equal, not a solution. Are equal is a solution. So just to really pound that home, hopefully. Here's one more example like that. Let's just do you can do all four, but my main focus is going to be these top two. Is -3, 4 a solution or not? And so drag your circles over there for this one. I'll just remind you for the 100th time that -3 is your x value for this first one, 4 is your y value. When I go to plug it in, then it would be 2 times -3. Just replacing that x with a -3, take away 7. That y is going to get replaced with a 4. And the question is, when I calculate that, probably using Desmos, do I find out that it's an answer of -11? I've got one good answer, and the same person already gave an answer for number 2, which is also a good answer. A reminder that Desmos likes to be my best friend, so I can actually put this 2 times -3, take away 7 times 4 right here into Desmos. Let me make it go away for just a minute. Come on. 2 times -3, take away 7 times 4. There's what Desmos tells me I get when I do 2 times -3, take away 7 times 4. And so then the question is it telling me I have an expression that is equal to -11? All right, about 30 more seconds here and we'll keep rolling. I'll show you guys the responses that are going on so far. And for the most part, where you see there's more stacked up, that's your correct answer. Malcolm, you certainly didn't have to run away, dude. Don't know. The answer is no. All right, so I'll hide responses real quick. when I put this in Desmos, if you remember, I got something very different from -11. So those of you, which is most of you, that put a no for -3, 4, I agree entirely. A yes for 5, 3 would be a correct answer. Does anybody have a question before we keep moving to the stuff that's really the more of the new kind of stuff?
Sponge Gar says no.
Thanks.
Yeah.
Okay. Whoops, not what I was after. After this guy. So those are the answers. We won't bother with it. But here are kind of some notes. Again, I've just done screenshots straight out of ALEKS. And here on the left, you see this is all about linear equations. And it's just sharing with us, there are really more forms, but the two most common forms of a linear equation are what, it doesn't identify the name of this one. This one happens to be called slope-intercept, and it's probably the one we'll use. It is the one we'll use the most as we are working with linear equations here. But then there's this other one, ax plus by equals c. That's called standard form. Whoops, I didn't even put that on there. So anyway, it's two forms of a linear equation. That's what I'm trying to get at here. And so you can just kind of look at these three examples here, which are anytime you see y equals, then if it's going to be a linear equation, it's going to be some number times x. This m is the some number plus some other number. Now, either of those numbers can be 0. That's what makes these other situations. So y equals 2x plus 10, we can pretty easily see that 2 is our m because it's the number right in front of x, and 10 is our b because it's the number that isn't a coefficient of x. But when we get here, the x has disappeared. That just indicates m must be a 0, and all we have is our b. So it's okay to just say y equals 5. That's still going to be a linear equation. And y equals 3x, well, that apparently means the b happens to be a 0, still a linear equation. So all three of these are linear equations. And then down here, I just want you to realize that it doesn't have to be in a y equals form. If you got an x and a y and a number, it doesn't even have to have both variables because a and b can also be zeros. So this 3x minus 5y equals -7, linear equation. Just x equals 4. That just means your b was a 0, and you just have 1x equals 4. So this is a linear equation. This is a linear equation. You see how the decimal points don't make any difference there? And then, sorry that my slide is a little cut off. I don't know if I can show that any better or not. Just trying to decide. Doesn't really look like it. So those are all things that are linear equations. Over here are the things that would make us realize it's not a linear equation. So really, as far as I'm concerned, these are 4 questions that you could ask yourself each time. And if you can answer all 4 of these things with a no, then you know it's a linear equation. So here we go. A variable raised to an exponent other than 1. You see every variable that shows up over here, it doesn't have an exponent written on it, but that means it has an exponent of 1. We don't normally write those down. But here you see that x has an exponent of 2, not a linear equation. X has an exponent of 3. It wouldn't matter if the y has an exponent of 5 or something. If either letter has an exponent besides 1 on it, then it can't be linear. Another one is if your variable appears as an exponent. You see how here y equals 5 raised to the power of x, so x is an exponent. That's not linear. This is actually called an exponential equation, which we will study. A variable that appears in a denominator. So fractions aren't a problem. The only problem is if your variable ends up on the bottom of your fraction, it's definitely not a linear equation. I can show you examples over here, like I can do y equals 2x over 3 minus 3/4. Fractions are fine. This is still a linear equation because there is no variable in the bottom of any of those fractions. Okay, the only problem is if you see a letter show up on the bottom of a fraction, you know it can't be linear. And then variables that are multiplied together. such as x times y is 2. If you see variables being multiplied together anywhere in your equation, then you know that's not a linear equation. Okay, so let's see if we can apply some of this. This first one is really going to just be focused on the top part, and the second one is where the second example we're going to do is where the other part will come into play. So here we go. Tell you what, I'm going to make it so we can go back and forth for the moment. So even though I want everybody right here working on this and dragging your circles to the appropriate answer, I just made it so that all of you can go back and forth. And the fact that I just went back to this doesn't keep you from staying on the page that I want people on. So here are the examples that we know are linear equations, and here are the 4 things. We can't have any exponents besides 1. We can't have a variable as an exponent. We can't have a variable in the bottom of a fraction, and we cannot have variables being multiplied together. Any of those would tell us right away it's not a linear equation. So, I see, yep, I see some correct answers. I could even make it, give you a humongous hint that might help you. There is only one of those 4 equations that is not linear. So see if you can find the one equation that's not linear. You can put yes for all the other ones and no on the one and only equation that is not linear. I'm liking these answers. I only see a couple incorrect answers. Here come, let's see, can oh, it would help if I go back to the one we're working on. All right, here's responses so far. We were doing quite well. Now we've got a few more that are a little out of whack. So which is the only one of those that has a problem that causes us to have to say that's definitely not linear? Anybody want to share? I like that all of you seem to see that D is definitely linear. All right, well, I don't see anybody answering my question at the moment. But you're all correct that y equals 8 definitely is a linear equation. The only equation that actually has a problem is this one that has an exponent besides 1. You see this x raised to the second power. That letter B has x being raised to a second power. And so that would be the one that is not linear. Only B should say no, it's not linear. Letter C, that negative sign bothers lots of people, but that's just some number times x. The sum number this time is -1 times x, and that would be linear. Okay, so letter C should say yes, it's linear. Letter B should say no, it's not linear. Alrighty, moving right along. Let's do this one last one. Let me just bring everybody here in case some of you are a little distracted at the moment. So everybody to example 4 is where I meant to go. Let me fix that. There it is. All right. So same idea here. And I would be asking myself the same 4 questions. Are there any exponents besides 1? Is there any letter that is an exponent? So if the answer to either of those is yes, then it's not linear. Is there a letter in the bottom of a fraction? That would make it not linear. Is there anywhere that letters are being multiplied together? That would make it not linear. So I'm one more time making it so you guys can make it back to where the page that has the notes on it is. I thought anyway. Did I fail too? Nope, I did. Okay. So I'm liking the answers so far. Notice these aren't the ones where y is all by itself. This is more like the ax plus by equals c stuff. And so far, I do believe that every answer is correct if I show those answers to you. Maybe. All right, now not every answer is correct, but it was just a second ago. That first one is a no because you got an exponent besides 1. The second one is definitely a yes. The third one is definitely a no because we're not allowed to have letters in the bottom of fractions if we're looking at linear equations. And the bottom one is a yes. So now we have all good answers again. Letter D is a yes. There's not anything that would cause that to be ruled out as a linear equation. All right, so we are down to 3 minutes in class here. As I said, even though the agenda is trying to tell you that this Alex assignment's due today, and I think even Alex says it that way right now, I'll change it. We'll make it due by the end of the day on Monday. I bet you were trying to share a link. Sorry. Go ahead and do that if you need to. As a matter of fact, I'll stop sharing my screen for now.